Okay, so in order to measure the LED's brightness, let's first take 220 ohm resistor and calculate the current. Okay. Now the current can be calculated using Ohm's law. Okay, Ohm's law. The Ohm's law is simple. V equals to IR, or I equals to V upon R, or R equals to V upon I. R equals to V upon I. V equals to I into R, or I equals to V upon R. Simple. They are all are same, right? So you can write the equation like this, right? Now let's put the value into this formula. V equals to 9 volt, R 220 ohms. My current would be V upon R, which is 9 divided by 220, and this should give me a value of what, 0.040 ampere, right? Now this 0.040 could also be written as 40 multiplied by 10 raised to power minus 3, or 40 divided by 1000, right? 40 multiplied by 10 raised to power minus 3 amps, or 40 milliamps, because 10 raised to power minus 3 is milli, right? Excuse me. So let me put this value into my table. Now the LED's brightness is maximum here. Okay, now I'll talk about that shortly in this video, but just for now, just let me write the maximum value, because I know this is the maximum. Now calculate the value of current for 500, 1 kilo ohms and 10 kilo ohms respectively. Okay, now I have already calculated it for you, so let me pull down the sheet. So here, as you can see, the value for 500 is 18 milliamps, 1 kilo ohm the current is 9 milliamps, and 10 kilo ohms is 0.9 milliamps, right? Clearly the value of current is reducing, and hence the brightness of LED. Okay, as the current value goes down, and so does the brightness of LED. Okay, and that's why I just put the maximum value here. See the value for current 0.9 milliamps, which is very low. So clearly when the value of resistance goes high, the value of current goes down, or vice versa, right? Now the conclusion is clear. So when the value of resistance is high, there would be, less current in your circuit. Since there would be less current in your circuit, the LED brightness would be decreased. Okay. Likewise, okay, let me separate this. Likewise, when the value of resistance is low, the current value would be higher in your circuit, which would give you a more brightened LED. Okay, or LED's brightness would be increased. Okay. Now just assume that you have connected an LED without a resistor in a circuit. Okay, which means you have applied a 9 volt voltage across a circuit, across an LED, and there is no resistance. What would happen? Well, just see the formula. I equals to V upon R. So the voltage that you applied across the LED is 9 volt, and the value of resistor is very less, some quantity 0.000 something. Let's pretend that, right? What would happen in that case? You'll find a very large value of current, right? A very large value of current, and this value of current would be the greater than the capacity of LED itself, or the rated capacity of your LED, which is not desired, right? This is more than what is desired, right? And your LED will burn. This is not desired. Now, this is one of the reasons why we don't connect an LED with less value or no resistor at all. This is one of the reasons why, or LED or any component for that matter, any electronic component for that matter, is not connected without appropriate value of a resistor.